Hey everybody, this is Eric with Shadow Ops RC. 2 weeks ago we did a intro to aviation basics, which applies to man and remote control. Okay, basically at the end of the day, planes are unstable on all three axes where a car is at, meaning up and down, which is pitch, side to side, roll, and then slip, which is yaw, nose, left or right. Okay. So there has to be a way to control the plane, because you have altitude, you have side to side, and so forth. Okay. Now, one of the reasons why the Wright brothers were successful at what they did was others figured out how to generate lift. They even figured out power. So how are we going to make this thing move? But the one piece that most people were missing was the controllability. With their gliders, they figured out that with lift and power, once you have the thing flying, you need to be able to control it. That's why they were successful. They focused on how can I fly this, okay? So keep that in mind. All these surfaces make the plane fly, but also they can be used to change directions on all three of those axes of the plane, okay? So we went over basic last time. So in this part 2, we're going to go over some terms that's to anybody in RC that's brand new, never been around electronics or anything. It's just a bunch of terminology that most people are not aware of. So, first things first, power. Most common, especially in RC planes, and getting more and more common, is electric power. So there's two types of electric motors used in RC. One's brushed, one's brushless. So in the brushless category, there's two segments. So outrunner and inrunner. Okay. I have a motor we're using for demonstration today. It came out of a 90mm EDF. We don't have to go over that today, but here it is. This is a brushed outrunner, meaning the shaft right here is driven by the rotation of the outside part of the motor, which you guys can see. Sorry the glare, guys, from that white line moving, okay? And it has 3 wires, okay? This is where your power is generated, okay? So, even if I applied electricity to this, it wouldn't work. We need something else to control. Not on here. You need inputs to tell us what to do. Dad, how fast or how slow.
I want some YouTube.
So you've seen both my twin daughters. They're crazy. Sorry. So you need another component. Well, multiple components, but on basics, if this was going in a propeller plane instead of an EDF, we would need a propeller or one other thing. And what that is an ESC. Every electric motor, whether it's brushless or brushed, needs an electronic speed controller. Okay? So this is a 100 ESC. You can't tell what brand it is because the label was over the cooling fins, and I cut that off to expose the fins. Okay? A lot of manufacturers don't expose the fins, and it's asking for overheating problems. So here's where those 3 connectors hook up. This big one with the huge wires and the XT90 battery plug is where the battery plugs in. This one, not only does it send power to the radio system in the plane, which we'll cover in a minute, it also gives commands through this to the motor on no power or power, or depending on where your stick is on your radio, that percentage of power, okay? You can't run this without this, okay? Now these are just these are for a bigger 90 millimeter plane, but they suffice for what we're going over today, okay? A lot of your rock crawlers or really small microplanes or helis will have brush motors because, well, for one, they're cheaper, and a lot of times you don't need the outright performance that a brushless inrunner or outrunner generates, okay? So, ESC, electronic outrunner, brush motor. There's also inrunners, which we don't have on this video, and brushed, okay? So, next we're going to go over a couple other terms, but I got to grab a few things to show you guys, so we'll be back here shortly. So off camera, you guys, I grabbed my radio, okay? This is the one that we create all the commands to go to our airplane, okay? By no means is this a plug for Tyrannus, aka FR Sky. This is just the radio I have, okay? It's a FR Sky Tyrannus QX7. It operates on OpenTX, which gives you a lot of flexibility in programming and stuff, but that is a topic for another day. This is a 16-channel radio, okay? So think of a channel as one line of command. So if you need power, throttle, that's one command. If you need roll, that's the second command, and so on and so forth, okay? Most planes are between a 3 and a 6. Now, the more you throw onto that plane, it gets more complicated. But that's okay. And this radio is a mode 2, meaning the throttle is on the, to you guys in the video, it appears on my right hand, okay? But what it means is throttle left, okay? And then on this side is your roll, and then your elevator up and down, okay? And then on throttle is also your rudder too, okay? We won't go into these switches today because it's not that big of a deal. If I gave this to somebody right now that didn't know what they're doing, these switches allow me to just basically put it in something similar to Spectrum's safe, okay? So, and this is a decal I have on it, okay? So, names for this. I'm talking what people call their radio, okay? Radio, TX. TX is abbreviation for transmitter. So if you hear somebody say radio, TX, or transmitter, they're talking about something similar to this to control your RC airplane with, okay? Think of the radio, TX, or transmitter as the quarterback. It passes what you want the plane to do to the airplane through another device. We're going to do a brief pause so I can grab one of my planes that has a receiver in it. And we can, because I don't have any outside of a plane right now. So we'll do that and explain what a receiver is. Okay, so I've grabbed my FMS Kingfisher, which is a short takeoff and landing high wing trainer, okay? This is just a battery hatch. The wires you see down here, this is the lead for the battery, okay? And then you see this black box up here with wires coming out, okay? That is an RX, or also called a receiver. So just like the radio we talked about just a second ago was the quarterback, the receiver takes the signals from the quarterback, the transmitter, and tells the plane what to do. So if I want a right roll, this aileron goes up and the left aileron will go down, and it will generate. So this is creating more lift on the left wing. This is decreasing lift on the right wing, which causes the plane to roll to the right. Okay. If I want a left roll, they switch. So right wing generating more lift now, left wing less lift. And so it rolls to the left. Okay. Every plane operates on those kind of principles. The flat part back here you see is the elevator, also called the horizontal tail, horizontal stabilizer, or even sometimes called feathers. Okay. It controls up and down. Okay. And it works on the similar to these ailerons. If it goes down, it creates more lift, which then moves the tail up. Okay. If it goes up, it generates less lift, and then the plane goes down. Okay. And then you have this part right here is a vertical stabilizer, which also houses the rudder, and it works the same way as an elevator and ailerons. It changes and decreases lift to cause the plane to move left to right. Okay. The tail, also called an empennage if you've been around manned aviation and planes a lot, comprises of the horizontal stabilizer, which contains the surface, the elevator surface for moving those up and down. The rudder or vertical tail is composed in the vertical stabilizer, and that's all the empennage. Okay. All these surfaces generate some kind of lift and stability in the air, and to get the plane to do what you want to do, you change that stability, which then drives the plane where you want it to go. So there's just a few. There is one other thing on this plane you can see right here on both wings on the inside close to the fuselage. Those are flaps. Those are solely used to generate more lift for takeoff and especially landing. On the little strip of grass I've been flying on, I literally put the flaps down like that. Not much, and you guys can barely tell. And I can crawl at like 30 or 40 miles an hour in the air. So, which is good because I'm still learning to fly. I know a lot about this stuff because I flew drones in the Army, so, which is a lot more highly automated, but it's also first person versus outside of the plane. So I'm having to learn, change my thinking and learning how to fly these. Okay. So I want to thank all my subs. Sorry for the drought. I know I say that every time. Being a combat veteran, it is what it is. Okay, you guys. So I'm sorry about that. Thank you for any new guys. If you have any questions, comments, don't hesitate to ask down below in the comments. Also, if you're new here, please subscribe. It helps. What else? On Friday evenings, I help do a vlog on Dave's RC. Another RC. He's primarily aviation, especially electronic ducted fan planes, where I kind of do a little bit of everything except for boats. I don't really do boats. But I live in a desert, so that's why. Without further ado, I hope everybody's having a great day. This is Eric with Showouts RC signing off, and wish you all a happy flying or RC driving.